name is Andrew. Welcome to my YouTube channel. So, here is a presentation about my AI project, traffic ambulance identification and verification system. And the contents in this presentation are the identified real-life problem, how the dataset will be manipulated to used to problem, factors considered before selecting the dataset in my project, and the dataset features that will be used by my AI model to solve this problem. Then also I'll talk about the Bayesian theorem, naive Bayes, Bayesian networks, their differences, and so my real life problem I identified is that many ambulance today have been delayed in heavy traffic, which incurs resulted in tragedy of victims, death of patients, delays in traffic, and this has negatively impacted the health sector. And how my dataset will be used to address this problem. It will be an image dataset taking image of taken images of ambulances that will be verified. That will be verified. Like it will take images of vehicles and to verify ambulances among those vehicles. Factors that I will consider before selecting a dataset for my AI project are: number one, type of data collected, whereby here the data that I collect will be basically image data because I want to verify images of ambulances. So if it's another vehicle, it's an ambulance, that will be verified as an ambulance. Then another one is how the data will be manipulated by the AI model. So for my data set, model will be manipulated using supervised learning technique. Because I'll use a training set that I'll compare with that I'll use for comparison to verify ambulances from other vehicles. Then another factor is how the data will be categorized in a data set. So in my data set, my data will be categorized according to, because they're images of vehicles. So they will be categorized according to the color, according to their size, according to their shape, according to their length, and according to their level. And last one is the quantity and the quantity of data stored in the database. So to prevent issues of biased models, I have to use a large dataset. Like it should be large so that I can prevent those problems. And the dataset and the data I obtain in large quantities will be through crowdsourcing. And through crowdsourcing, I believe I'll get more and more data. And, so the dataset features that I will use in my AI model to solve the problem. It's basically how I'm going to categorize my data to use. Now, as I said earlier, data will be categorized according to the image size, shape, the color, the label, and the length. So going into Bayesian theorem. So it describes the probability of an event based on a prior knowledge of conditions that might be related to an event, or it relates, in other words, it relates the conditional probability and the marginal probabilities of two random events. And now here we have a scenario taking an example of events A and B, and the marginal probability will be the probability of B given A, which means that event B will occur given that event A is the event A is true. Then from the equations below, as we see, the probability of A and B will be the probability of A given B multiplied by the probability of B, and at the same time, the probability of A and B will be the probability of B given A multiplied by the probability of A. So in these two equations, since A and B are the same, so we will equate them. Equation 1 will be equal to equation 2. Therefore, it will be that and the probability of A given B multiplied by the probability of B is equal to the probability of B given A multiplied by the probability of A. So from this equation, we can derive the Bayesian theorem. So the Bayesian theorem is the probability of evidence, as we see here, which was equal to the posterior probability multiplied by the marginal probability out of the prior probability, which is the probability of event F, and the probability of evidence is the probability of the event F. So for the naive bias classifiers as probabilistic classifiers based on applying bias. So it's like it is something like bias there, but with a strong independence assumptions given between the features, meaning that naive bias it's basically works on mutually independent events, but as we saw earlier in the Bayes theorem, the events have to be dependent on each other. So we have the steps here. We have the training, whereby we calculate the mean variance prior frequency of the prior frequency of each class, and also the prediction where we calculate the posterior for each class. Then the way which is choosing the class with the highest posterior probability. So below is how the naive Bayes equation is expressed, as whereby you have probability of C given X is equal to the probability of X given C multiplied by the probability of C given over the probability of element X, and the probability of C given X will be equal to the probability of X1 given C multiplied by the probability of X2 given C, and to the probability of X given event X, any given event Xn given probability of C multiplied by the probability of C. Now here, probability of C given X is the posterior probability according to the predictor X for the class C, and probability of C is the probability of the class Bx, and that is the probability of the predictor, and probability of X given C is the probability of the predictor for the particular class C. And now for the Bayesian networks, they fall under the category of probabilistic graphical modeling, PGM technique that is used to compute uncertainty by using the concept of probability. And now for this case, for the Bayesian networks, we use what we call directed acyclic graph, that is used to represent a Bayesian network like any other statistical graph, and has a set of nodes and links. Now these nodes and links are nodes. There are various nodes and they are connected together through links. Now a node, what I mean by a node, it is a set of random variables, and these variables can either be discrete or continuous. And now for the links are the arrows connected to pairs of nodes and showing the relationship between those nodes. The present Bayesian networks are based on number one, joint probability, which is the measure of the events happening at the same time, and they are also based on the conditional probability. For instance, you have an element B, which is the probability that that event will occur given that event A has already occurred. As you can see, probability of B given that A has occurred. Now, for these Bayesian networks, for depending if the condition is if they are dependent, the probability of B given A will be probability of A and B over the probability of A. And if they are independent, if B and A are independent, it will be the probability of B given A will be equal to the probability of B only, because A and B are independent. So here we have the differences between the Bayesian theorem and the naive Bayes. So for the Bayesian theorem, it assumes that some features are dependent on each other, while for the naive Bayes, it assumes that all features are mutually independent. Another difference is that the Bayesian theorem, it relates the conditional probability and marginal probability of random events, while for the naive Bayes, it relates the prior and the posterior probabilities of events. Then another difference is that it's mainly used in the Bayesian theorem. It's mainly used in model comparison and parameter estimation, while for the naive Bayes, it is mainly used to solve classification problems. So maybe another thing for the naive Bayes theorem, the naive Bayes, it is used in unspecified learning, not specified learning. Now, for the difference between the Bayesian networks and the naive Bayes, the Bayesian networks are based on joint and conditional probability, while the naive Bayes is based on prior and posterior probabilities. Then another thing for the Bayesian networks, they assume that some features are dependent on each other, but for the naive Bayes, they assume that all features are mutually independent of each other. Then the Bayesian networks help in online data learning and decision making, while for the naive Bayes, they are mainly used to solve classification problems. And here are some of my references where I got my work from Quora, www.upwork.com, and www.bootstrap.com. Thank you so much. This is Andrew. Peace out.